There are objects in this universe capable of emitting light trillions of times brighter than our own sun. Let's find out what they are. Hey everyone, my name is Kevin and I'm a PhD student working with Astro 3D. Today we'll be creating a model of one of the most fascinating objects in the universe, the quasar. Now the quasar is what we call a supermassive black hole that is actively accreting a fantastic amount of material, and in the process of doing so emits immense radiation. These are among the brightest objects in the universe, with many of them easily shining brighter than 1 billion or even 1 trillion suns. So for today, we'll be making this particular quasar out of ice cream and decorating it with a variety of other ingredients as we explore what makes quasars so interesting for astronomers. So for the first part, we need to build our black hole. Now black holes are objects that have collapsed due to their own gravity, and they're special in the sense that these objects are so dense and so compressed that not even light can escape from its own gravitational pull. Well, up to a certain distance at least. And this is why they appear black to us. Now black holes can come in two broad size groups. First, we can have your garden variety, stellar mass black holes, which can weigh from anywhere between a few solar masses up to a couple of hundred solar masses. In our own Milky Way, astronomers estimate there can be anywhere between 10 million, even up to a billion of these stellar mass black holes. Second, we have our supermassive varieties, which can have anywhere between tens of thousands of solar masses up to 10 billion solar masses. Typically, we only have one supermassive black hole in the center of every galaxy. So even for our own Milky Way, our supermassive black hole is about 4 million solar masses, and it is towards the direction of the constellation Sagittarius. Unfortunately, I do not have the necessary ingredients today to build a black hole right in front of me, so we're going to have to make do with a few alternatives instead. So for this black hole ice cream, we only need 2 ingredients, plus any type of coloring you'd like to make your black hole dark in color. This ice cream does need a bit of elbow grease to make, so feel free to get your family and friends to help out. So this is what I have for about 4 servings. First of all, we'll have one medium-sized jar that is freezer safe, or if you don't have a jar that can be stored in the freezer, you can make this ice cream in any jar and just pour in a separate container to store in the freezer. There needs to be enough room in this jar such that when you pour the mixture in, the mixture can freely move around to incorporate air. Next, we have about 1 cup or 250 ml of cold thickened cream or cold heavy cream. Then we have about 1/4 cup or 4 tablespoons, approximately 60 ml of cold sweetened condensed milk. Now these 2 ingredients will build our base of our ice cream. And the coloring of my black hole will be made from, in this case, about 1/4 cup or 4 tablespoons, about 30 grams of black sesame powder. And I'll also be throwing in some crushed Oreos just because I have some lying around. Feel free to use your own ingredients such as Milo, cocoa powder, or even blueberry jam to achieve the perfect black hole. Now what I'm going to do is I'm going to carefully pour all these ingredients into the jar and give them a little stir. I'm going to screw the lid on tight and shake. And initially what you're going to be hearing is that you're going to be hearing the ingredients splash around, but over time the mixture will begin to thicken up. And this process can take anywhere between 4 to 6 minutes. When the mixture stops splashing around as much, then you know it's time to stop. But be a bit careful because it's possible to overmix this and you can end up with a quite grainy ice cream. So after about 4 minutes shaking, the consistency should look something a bit like this. At this point you can choose to keep this mixture in your jar and just all pour in a separate container. So what I'm going to do is I'm going to smooth the surface of this and just pop it in the freezer for about 4 hours. Now this is a container I prepared a bit earlier, and now we can plate out our model. So what I'm going to do first is I'm going to take a big scoop of my black hole ice cream and place it right in the middle of my galaxy. Now I won't be doing a size accurate portrayal, as the size of the supermassive black hole is extremely small compared to the extent of the galaxy. And if I was to do it accurately, chances are you will not be able to even see the black hole ice cream on my plate. Now for the decorating. Since I'm doing a model quasar, we need to have the supermassive black hole gobble up material from accretion disk. So here's some red biscuits that will be the material for my accretion disk. Now this accretion disk is essentially made of loose collection material that is orbiting and spiraling around a black hole. And this material is typically just cosmic dust, but can also be stray stars that have wandered too close. So meanwhile, as this stuff spirals and spins, it mashes around and around with each other, and getting incredibly hot from friction and gravitational forces, which in turn causes it to shine extremely brightly. This friction and radiation causes material to lose energy. This cosmic dust gradually begins to spiral in towards the black hole, effectively feeding it and making it grow. Now, this growth by accretion is one of the primary mechanisms that allow a supermassive black hole to reach billions of solar masses. In the early universe, around 13 billion years ago, there was abundance of gas, which allows for the accretion to be continuously replenished and the supermassive black hole to continuously grow. And over time, this available gas in the galaxy will begin to dwindle, because the gas will eventually become building blocks for stars, planets, and other fascinating objects. So the accretion disk eventually runs out of juice and the quasar begins to fade. So for a long time, the supermassive black hole will remain dormant. And it will remain dormant until a stray galaxy collides into this one, and one is a bit too close to the central black hole to capture some fuel. So now the accretion disk is once again fueled, and the supermassive black hole becomes a quasar again. And this quasar will continue to shine brilliantly while the mass is deposited into the central black hole. The radiation will last as long as the accretion disk remains. So here it is, my supermassive black hole ice cream. The portion size is definitely supermassive, and I'll definitely need help to finish this. Hope you enjoyed this video. The universe is a fascinating place. Let's go exploring.
Astro 3D is the Australian Research Council's Centre of Excellence for all-sky astrophysics in 3 dimensions. Our astronomers are searching to understand the evolution of the matter, light and elements from the Big Bang to the present day. This Astro in the Home series is your opportunity to unlock the secrets of the universe with your own 2 hands. Find out more by visiting our website, following us on social media, or subscribing to our YouTube channel to be notified whenever we upload new content. Now, go explore the universe.